with this packet, and again, make sure you open up the worksheet before you really get into the video, but this is a little bit closer to what we were doing before break, where we can evaluate an integral by taking the antiderivative. Remember, capital F is the antiderivative of little f, and we can plug in the numbers on the top and bottom and subtract. So this first example, and a lot of the problems on this packet are going to be different applications than what we did before break. So for this, a lot of this you're going to need your calculator for, so you might want to go ahead and find your calculator. Otherwise, this first example is not a calculator example, but if we want to evaluate the integral from pi over 2 to x of cosine, what we would do first is find the antiderivative of cosine. So what has a derivative of cosine? Sine has a derivative of cosine. So the antiderivative of cosine is sine. And then what we do with these numbers here, and I'm sorry that they're typed so closely together, but what you do is you plug in the top number first, so sine of x, and you plug in the bottom number second, sine of pi over 2, and you subtract those two numbers. Well, really, sine of x is not a number, it's an expression, but you subtract the two expressions that you have. Sine of pi over 2 is -1, so that's how that simplifies. So this looks a little different from what we did before break because we have an x on top of the integral instead of another number. And this next problem here is going to feel a little bit different. So what we have, g is the integral of f, and let me see if I can get rid of some of this. Okay. So g is the integral of f, and you could be asked to find a few different things. You could be asked to find a function value, a derivative value, or a second derivative value, and you want to be able to do any of those three things. The first, and you can see the work done out on the left of the screen over here. I'm going to kind of recreate it and narrate it a little bit over here. G of 6, so if we know that g of x is the integral of -4 to x, then to find this integral, we would plug in 6 for x. So g of 6 goes in for x, of f of t dt. This integral, so we have a few different ways to evaluate the integral. We can either use an antiderivative. If we don't have the ability to find the antiderivative, then we would have to do area. And that's what all this work over here is finding the area. From -4, 1, 2, 3, 4. So -4 starts here to 6, 1, 2, 3, 4, 5. Oh, last count. 1, 2, 3, 4, 5, 6. 6 goes to here. The area that they're looking for are these spaces, and that is what is shown on the left of the screen over there. It's wrapped around into two lines, that's why it looks so weird, but you have triangle, negative triangle, and then it looks like that other space they split into a triangle from this triangle. And then 3 times 4 is this rectangle. And the last one, 1/2 times 2 plus 4 is this last space, and it looks like they took it as a trapezoid. So for the first part of this question, finding g of 6, evaluating an integral, we can do that by taking area. For part B, this is a little bit more like what we did in the first note packet. If I'm looking for g prime of x, the derivative of the integral, they sort of undo each other. The derivative of g is just f, so g prime of 6 is f of 6. And if we look at f of 6, 1, 2, 3, 4, 5, 6, 6 is here. This y value is 2, so the answer is 2. And then lastly, if g prime is f of x, then the second derivative of g is f prime of x. So to find the second derivative at 6, we need the derivative of f at 6. Well, at 6, we're looking at this point here, and this is the graph of f of x. So f prime is going to be the slope of this section right here. So for this, f prime of 6, we're thinking slope. The slope of that segment is -2. That's why that turns out to be the answer. So for this, we're thinking slope. Okay, so these are more of what you might see on a free response type thing. The multiple choice, we're going to go through together. It looks like number four I flagged in my notes is something we don't know how to do yet. So first I'm going to do 1 through 3, and these are all calculator questions, so make sure you have your calculator handy. What we know that f is an antiderivative of this. F of 1 is 2, and f of 3 is what we're looking for. So if we know that f is an antiderivative, then f is an integral. So we need to set up some sort of integral of this expression, root x over 1 plus x cubed. So what we know over here, we know something about f of 1. We're looking for f of 3. So we care about the x values 1 and 3. So we're going to set up an integral from 1 to 3. And we're going to do that for each problem on this sheet. So we always look at which x values we care about. On the next one, it's -1 and 5. -1 and 5. So we're going to end up setting up an integral between -1 and 5. So we set up an integral from 1 to 3 because those are the two x values we care about. One we know, the other one we're looking for. So we need to finish this expression here. So we know that f is the antiderivative of this expression. So if f is the antiderivative, then this integral should be equal to f of 3 minus f of 1, because that's how we would evaluate this. If we could take the antiderivative of root x over 1 plus x cubed, if we could take its antiderivative, we would plug in the top number, and we would plug in the bottom number, and we would subtract in the middle. So here, we don't know what the antiderivative of root x over 1 plus x cubed is. But we do have a way to evaluate this in the calculator. Your calculator can do this. If you don't remember, you go into Math, and you want option 9, which is going to give you the FN int menu, or that's what it's called, and you get a little fill in the blank. So pause this video, try to plug in this integral, and see if you get what I get. When I did this, I got 0.397. So that whole integral is equal to 0.397. And what we're going to do on the right side, f of 3 we don't know, but we know that f of 1 is equal to 2. We were told that back here, f of 1 is equal to 2. If we're looking for f of 3, all we have to do is add 2 to the other side. And we have our answer. So looking at that example, see if you can pause this video and try number 2. The answer for 2 is going to be C. So if you got that, you can skip the explanation and just move to the next problem. So for this problem, we know that f prime is cosine x squared minus 1. F of -1 is what we have. F of 5 is what we're looking for. So We care about the x values -1 and 5, so we're going to set up an integral with -1 and 5. And what we know is the integral of the derivative, so cosine of x squared minus 1, would be equal to f of 5 minus f of -1. And again, we need to evaluate this because we cannot take the antiderivative of cosine x squared minus 1. We don't know what that is. But we can plug this into our calculator, this whole thing. Don't forget to double check that you're in radian mode and try to plug this in. If you want to pause this, try it, and then check your answer. That is what I would suggest. I got 1.524. We're looking for f of 5, and we know that f of -1 is 1.5. So to get the f of 5 by itself, we just need to add 1.5 to the other side, and I'm going to get 3.024. Okay, so the next problem is really similar, so why don't you pause this video and give it a shot. The answer to number three, the answer is going to be A. So we know g is the antiderivative. We know g of 3 is 7. We're looking for g of 0. So the x values we care about are 0 and 3. So I have an integral from 0 to 3 of the derivative. The derivative is this mess, the square root of x to the 4th minus 3x plus 4. So the integral of the derivative is equal to g of 3 minus g of 0. This evaluate in our calculator. When I plug that into my calculator, I got 9.967. We're told that g of 3 is 7, and we're looking for g of 0. So if I subtract my 7, I have 2.967, and that's equal to negative g of 0, so g of 0 must be negative 2.967. And it looks like my answer doesn't perfectly match any of theirs, but it is close enough to A for me to feel pretty confident that that's my answer.